NASA just announced something that changes everything we thought we knew about the moon. And no, this isn't about going back just to plant a flag. I'm talking about trillions of dollars in resources, a new space race that's already heating up, and technology that could literally power Earth for generations. Right now, while you're watching this, multiple countries are racing to claim territories on the lunar surface. Not for science, for control, because whoever gets there first writes the rules. And what I'm about to show you isn't some distant future fantasy. This is happening now. The decisions being made in the next few years will determine who controls the most valuable real estate in the solar system. So let me break down the 5 reasons NASA is obsessing over the moon and why you should actually care. There are 5 critical reasons why NASA is watching the moon more closely than ever before, and each one is reshaping humanity's relationship with our nearest celestial neighbor. What started as a simple return mission has evolved into the most complex space endeavor since Apollo, driven by resources worth trillions, geopolitical competition, and the foundation for our multi-planetary future. Now, before I get into the specifics, let me tell you why this matters to you. Because this isn't just about astronauts and rockets. The resources on the moon could solve energy crises, fund entire economies, and determine which countries lead the next century, and whoever controls those resources controls the future. The first reason is water ice, and we're talking about quantities that could fundamentally change space exploration forever. The moon's polar regions contain an estimated 6 trillion kilograms of water ice, spread across permanently shadowed craters that haven't seen sunlight for billions of years. More than 40 craters near the North Pole alone are believed to hold 600 million metric tons of frozen water. That's not just a scientific curiosity, it's rocket fuel, drinking water, and breathable oxygen all waiting to be harvested. This discovery completely rewrote our understanding of lunar resources. During the Apollo era, soil samples showed no signs of water, leading scientists to conclude the moon was bone dry. That assumption held for decades until 2009, when NASA's L-Cross mission deliberately crashed into the CLPS crater and detected water vapor in the debris plume. Then, in 2020, NASA announced they'd found water even on the sunlit portions of the lunar surface, proving it's far more abundant than anyone imagined. So what does this actually mean? It means the moon isn't just a destination, it's a gas station, a refueling depot for missions to Mars and beyond. And whoever controls that water controls access to the entire solar system. For any country seeking a permanent lunar presence, controlling access to these water deposits is essential. Water ice can be split into hydrogen and oxygen through electrolysis, providing both rocket propellant and life support systems. This means the moon could serve as a refueling station for missions to Mars and beyond, dramatically reducing the cost and complexity of deep space exploration. The second reason is helium-3, a rare isotope that could revolutionize energy production on Earth. While our planet contains less than 25 tons of helium-3, the moon holds between 650,000 and 3 million tons of this precious material, deposited by billions of years of solar wind bombardment. Just 25 to 30 tons of lunar helium-3 could theoretically power the entire United States for a year through nuclear fusion. Think about that for a second. One mining operation on the moon could power an entire nation for a year. That's not science fiction. That's why companies are already planning commercial mining operations. At $20 million per kilogram, we're talking about the most valuable commodity in human history. This isn't just theoretical anymore. In 2024, an American startup called Interloon announced plans to begin commercial helium-3 mining operations, securing over $300 million in agreements to supply the material for quantum computing applications. At $20 million per kilogram, even small-scale extraction could prove enormously profitable. Interloon's CEO Rob Meyerson believes they can build a viable business just targeting quantum computing needs over the next 5 to 7 years. The moon's helium-3 concentrations vary dramatically across its surface, from 1.4 to 15 parts per billion in sunlit areas, potentially reaching 50 parts per billion in permanently shadowed regions. The solar wind that deposited this treasure trove has been raining down on the lunar surface for eons, creating what may be the most valuable real estate in the solar system. The third reason driving NASA's lunar focus is an accelerating space race with China that's reshaping global space politics. While NASA works toward its Artemis 3 landing planned for 2028, China has announced its intention to land taikonauts on the moon by 2030. This isn't just about national pride, it's about who writes the rules for lunar resource extraction and territorial claims. And here's where it gets serious. This isn't like the Cold War space race. This is about territory, about resource rights, about who gets to mine trillions of dollars worth of materials. And right now, there are no international laws governing who owns what on the moon. Former NASA Associate Administrator Mike Gold captured the stakes perfectly when he said the countries that get there first will write the rules of the road for what we can do on the moon. Vice President Mike Pence echoed this urgency in 2019, declaring we're in a space race today, just as we were in the 1960s, and the stakes are even higher. The geopolitical divide is stark. The Artemis Accords, signed by 61 countries as of 2026, represent one vision of lunar governance emphasizing transparency and peaceful cooperation, but notably absent are China and Russia, who are developing their own international lunar research station with a completely different set of partners. Beijing is making its alternative attractive by offering low-interest loans, technology transfer guarantees, and payload slots on Chinese missions to countries that join their program. China's progress has been impressive and steady. In August 2025, they successfully tested their Lanyu lunar lander, validating critical landing and liftoff capabilities. Their Chang'e 6 mission in 2024 achieved something even NASA hasn't done yet, returning samples from the far side of the moon. China's systematic approach includes establishing a permanent lunar base between 2028 and 2035, followed by crewed missions to Mars. The fourth reason is NASA's ambitious Commercial Lunar Payload Services program, which is fundamentally changing how we explore space. Rather than building everything in-house, NASA is partnering with private companies to deliver scientific instruments and supplies to the lunar surface. NASA has awarded roughly $1.5 billion in contracts for 12 missions through 2028, with a total program value of $2.6 billion through November 2028. This approach has already achieved historic milestones. The IM-1 mission in 2024 marked the first successful commercial lunar landing in history. Firefly Aerospace's Blue Ghost mission in March 2025 completed a flawless landing near Mons-Lettre, even attempting the first GPS lock from the lunar surface. These successes prove that commercial companies can dramatically reduce costs while maintaining scientific capabilities. However, the program hasn't been without challenges. Of the 4 CLPS missions completed by 2025, only Blue Ghost was deemed a complete success by both NASA and the vendor. Casey Dreyer from the Planetary Society notes the uncertainty, saying we don't know if CLPS works yet as a concept, but NASA administrator officials remain optimistic, pointing out that 5 years ago, no commercial lunar lander existed, and now multiple companies are regularly delivering payloads to the moon. The fifth and perhaps most significant reason is the Lunar Gateway space station, representing humanity's first permanent outpost beyond Earth orbit. This multinational project involves NASA, the European Space Agency, Japan's JAXA, and the Canadian Space Agency, with the UAE providing the crew and science airlock module. The Gateway will serve as a staging ground for lunar surface operations and a stepping stone to Mars. This is where it all comes together. The Gateway isn't just a space station. It's humanity's first permanent foothold beyond Earth orbit. It's the launching pad for Mars missions. It's the command center for lunar operations, and it's launching in less than 2 years. The station's power and propulsion element and habitation and logistics outpost are scheduled to launch together no earlier than 2027 on a SpaceX Falcon Heavy rocket. By 2028, the Gateway should be supporting science and technology demonstrations, with the first crewed assembly mission planned as part of Artemis 4 in late 2028. ESA astronaut Alexander Gerst describes the vision as building a space station that's set to orbit the moon as a base station, as a base camp to go down to the surface. The Gateway's baseline cost of $5.3 billion reflects its complexity and importance. Unlike the International Space Station's permanent Earth orbit, the Gateway will follow a unique near-rectilinear halo orbit around the moon, providing consistent communication with Earth while offering access to the entire lunar surface. All of these factors converge in the Artemis program, NASA's most ambitious undertaking since Apollo. Artemis 2, scheduled for March 2026, though likely delayed until April due to helium flow issues, will carry 4 astronauts farther from Earth than any human has traveled since Apollo 13. The crew includes Commander Reed Wiseman, pilot Victor Glover, who will become the first person of color to travel around the moon, mission specialist Christina Koch, who will be the first woman, and Canadian Jeremy Hansen as the first non-American. Looking ahead, NASA plans yearly lunar landings after Artemis 6, with Artemis 7 expected to deliver 4 astronauts to a permanent surface habitat called Foundation Habitat in March 2032. These aren't just flags and footprints missions. They're the foundation for a permanent human presence on the moon and the launching pad for Mars exploration. NASA's intensified focus on the moon represents more than scientific curiosity or national prestige. It's about securing access to resources that could transform human civilization, establishing the framework for space governance, and taking the first steps toward becoming a truly spacefaring species. The decisions made in the next decade about lunar exploration and resource utilization will echo through centuries of human expansion into the solar system. So let's quickly go over what we just covered. 6 trillion kilograms of water ice, up to 3 million tons of helium, 3 worth trillions, a new space race between superpowers, commercial companies landing on the moon, and humanity's first permanent outpost beyond Earth orbit launching in 2027. This isn't science fiction. This is happening right now, and the decisions being made in the next 5 years will determine who controls the most valuable resources in the solar system. But here's the uncomfortable question nobody's asking. What happens when countries start claiming lunar territory? What happens when mining operations conflict? What happens when there are no international laws to settle disputes, and both sides have nuclear capabilities? Because right now, we're building the infrastructure, we're establishing the bases, we're sending the crews, but we haven't figured out the rules yet. If you want to understand what's really at stake here, check out that video right now, because once you see how fragile our space governance actually is, you'll understand why the next decade could be the most critical in human history.